So representing text, this is part of Unit 3, just after the binary stuff and before the slightly more funky and complicated stuff. Basically, whenever you type letters in from a keyboard or characters from a keyboard, there has to be a way of storing those away in the computer. Now we know that all data and instructions for that matter that are inside computers have to be stored as numbers, and we know that those numbers have to end up eventually as binary. Now, we're not going to look at any binary today, but you can always think that the numbers that we are going to use, they do actually have to end up as binary in the end. Okay, so we need a way of turning text into numbers. And it's really important that everybody uses the same way to do this. Obviously, if my letter A is recorded as number 4 and your letter A is recorded as number 7, then we'll get very confused when our computers try to speak to each other. So the first way that you need to know about to do this is something called ASCII code. ASCII stands for American Standard Code for Information Interchange, and it's a way of storing basic keyboard characters that you'd find on a standard American English keyboard. ASCII code is pretty basic. It only allows you to store 128 different possible keyboard characters. Now these are the standard characters that you'd find on an American English keyboard, not a British English keyboard, not a French keyboard, but an American English keyboard. The A in ASCII stands for American, remember. And it was a way of getting information from one side of America to the other side of America quickly in text format. Okay, no pictures or anything like that back in those days. So this is a teleprinter machine. It's the sort of thing that you type in one end and then the message would come out in San Francisco or wherever else you were sending it. And these are the standard sorts of characters that you see on the keyboard that you've probably got in front of you right now, pretty much. So ASCII is fine for transmitting basic text. ASCII uses 7 bits of memory per character. Okay, so you've got 128 different possible characters, 0 to 127, remember. Now, that's because data transfer is actually quite a difficult thing to do back in the 1960s. You didn't have high-speed internet back then. We had telephone wires, copper telephone wires. So moving characters around took a lot of time per bit of memory. So by cutting down the number of different possible characters, you could reduce the problems with data transfer speed. So the data transfer speed becomes reasonable. You can get a message from New York to San Francisco, essentially. Before ASCII code, with its 7 bits, there was a system that only used 5 bits of memory. 5 bits of memory, 32 characters. So you've literally got the letters of the alphabet and then a few other characters. Now the table here is the ASCII table. As you can see, my one here goes from 032 up to 127. Now the characters from 0 to 31 are actually non-printing characters. They do things like put a blank line in, for example, and there are some command characters that messages need to have at the start and at the end. Okay, and then you've got your basic keyboard characters. So 032 is space, 065 is a capital A, 097 is a lowercase a, for example. And you can combine those characters to create numeric codes for messages like this. Remember, everything stored in a computer is stored as a number. These numbers would eventually get turned into binary numbers, of course, but as far as we're concerned, we can just look at them as digital numbers. So by looking back at the table, you could actually translate this message. So one of the key things about the ASCII table is that the letters are grouped, or the characters rather, are grouped. So 65 to 90 are the capital letters, 97 to 122 are the lowercase letters, and all the numbers are in one group as well. Okay, so if you know, and this is a common exam question, okay, it's just a bit of simple logic of working out the answer. So if you know that 077 represents the letter M, then they might ask you in an exam, okay, so what represents the letter R then, capital R? So M, N, O, P, Q, R, that's 5 letters on, 77 plus 5, 082. Okay, and then what letter is represented by character code 074? Well, that's 3 less than 77, so I've got to go 3 less in the alphabet. From M, I find doing the alphabet backwards quite difficult, so J, K, L, M, it'll be K, because that's 3 letters before. It really is just a case of writing down the alphabet if necessary and doing the calculations. They'll never give you anything that goes from uppercase to lowercase. They could say, hey, 103 is whatever it is, F or whatever, what's 107? Okay, so just summing up then, 0 to 31 is non-printable for those sorts of reasons. You've got the delete key, the backspace key, those sorts of things. It's, you know, they have to have ASCII codes because they're on the keyboard. Okay. So one of the big problems with ASCII code is that it's limited to 128 characters. That means that none of the words in the bullet list that you see on the screen could be represented using ASCII code because they all contain characters that aren't on a standard American keyboard, whether that's be accents or the Cyrillic alphabet or whichever Chinese alphabet that is, or the pound sign, because Americans don't have pound signs on their keyboards. So how do we get over the problem? We developed something called Unicode. Unicode was first developed during the 1980s as a replacement for ASCII because by then, very clearly, it was limited. Okay, it didn't have any support for different alphabets, didn't have any support for special characters. That actually stopped an awful lot of people being able to communicate. One of the key things that you need to know, and you absolutely need to know this because it could be a question, is that the first 128 characters are the same. Why did they do that? Well, if you don't do that, you can't actually go back to anything old and use it. So because the first 128 had already been set in ASCII, they are the first 128 in Unicode. Now Unicode started with a few thousand characters. It's now up to getting on to 150,000 different characters, different alphabets, those sorts of things. Okay, even emojis. It's very sad, but when you put an emoji in on your phone or whatever, that's got a Unicode character associated with it. So when Apple roll out the next set of emojis, or whoever rolls out the next set for your phone, then those have to have Unicode values to go with them. Now, one of the problems with Unicode, and you do need to know about problems with Unicode because it's not a perfect solution, is it takes more memory. At the minute, they're using 16 bits per character. That's more than double what ASCII code does. Now, that's a problem in very, very simple systems with very, very limited memory. So, you know, the processor that's in a washing machine, for example, something that is called an embedded system. We'll come back to that later during the year. Okay. It also causes a problem for transfer speed, and it means you can't use Unicode stuff on really old technology. And, you know, that's even true today with fairly modern phones. So my very old iPhone 4 doesn't have certain emojis on it. So when one of my sons sends me a message with a badger emoji in it or something like that, I don't have the badger emoji, so I just get a strange question mark box come up. Because my technology is too old, it won't support the new version of Unicode. It's a really important idea that actually technology has to be able to cope with old systems still, because old systems are actually really important in lots of different places. We'll come back to that idea at some point during the course. So here's another key question that you might have to be able to answer. For example, advantages of ASCII rather than Unicode, or advantages of Unicode rather than ASCII, or disadvantages of Unicode, or disadvantages of ASCII. Okay, any of those ways of asking essentially the same question. So limited characters within ASCII, more characters in Unicode, support for different languages so people from all over the world can communicate effectively, but memory, data transfer speed, and the problem of going backwards to old school technology and that still being able to understand it. So that's one of the key questions that you could easily see in an exam. And then I've shown you a question like this already, but this is the other sort of standard key question that might come up, this sort of thing. Okay, not hard to do as long as you understand what ASCII code is and how it works, and that the various different types of character tend to be grouped together. So that's pretty much everything you need to know about the ways that we represent text. The key thing is everything comes back to numbers. Those numbers end up as binary. We need to all be using the same numbers, because if my 81 isn't Q and you send me a 081 which you think is Q, I'm not going to be able to understand what you're saying, and that's bad.